Hi there, welcome to 42 Pursuit. I'm Gavin, and in today's video, we're gonna be fixing this catastrophe that is my current tinkering space in my office. We're gonna do that by building a primo maker's desk with a slant towards electronics development. If that's something you're interested in, stick around. And if that's not something you're interested in, why are you here? Nah, just kidding, you're welcome to. First step is making some legs for this aircraft carrier. I threw them together in CAD so I could get the dimensions all dialed in. Now this may surprise you, but I'm not a fan of hitting my knees on things, so I designed the narrowest part of the legs to be at knee height, and of course threw some caster wheels on the bottom. Now that I've got the dimensions all figured out, let's head to the shop and start cutting some metal. Okay, just to level with you, I'm a little bit nervous about this next part. I have virtually no experience working with metal, but I've always wanted to learn how to weld. Just the other day I picked up a welder, so I thought what better time than now to break it in and make some legs for this desk. We're gonna start with 3 by 1.5 inch square tubing and some flat bar, cut it to size with an angle grinder, tack it together, and hope for the best. Let's do it. I quickly figured out that clamping down a scrap piece of metal and using its edge as a reference for the grinding wheel drastically helped keep my cuts straight and on the line that I was cutting to. With all the pieces cut to size, mounting holes are drilled and countersunk. To make sure nothing bad happens if there's any wood movement in the desk surface, the front mounting holes are elongated, so there will be room for the wood to expand and shrink as the humidity changes throughout the year. Okay, we're back at the computer because I think I figured out a slick way to make sure all of these pieces get welded together accurately. Since this is in CAD, what I can do is draw a bounding box in this region here and then create a cutout that I can cut on the CNC and use that as a clamping jig to weld everything together. It's gonna look something like this. Whoops, not enough room for a clamp. And there we go. Not as pretty, but it'll do. And now it's welding time. I'm new at this, as I mentioned before, but from the research I did, I kept hearing how the joints needed to be clean and clear of mill scale. After a few welds that didn't quite seem right, I realized that mill scale isn't necessarily a scaly texture, but in my case it was actually the smooth and hard outer surface of the metal. A quick pass with a flap disc exposed the clean and brighter metal underneath, and that clean metal welded much better. Once all the pieces were tacked together, all the joints were then fully welded. And because I want a smooth and filleted look on the legs, I went back through and ground down all the joints. And the same process for the uprights that will hold the upper shelf. Okay, the bases are done. The welds aren't pretty, but not bad for a first try, and the metal's sufficiently stuck together, so I think it's gonna work. I'm gonna wipe these down with acetone to clean them up, throw a coat of primer on, and then let them dry overnight. The next morning was a quick welding of the casters, masking, and a few coats of paint. And the legs and uprights are done. Now onto the desktop and shelf. They're both going to be made out of some blue pine that I picked up off of Craigslist a few months back. Now, pine isn't the most robust material for a work surface, but it's what I had on hand, and I've got an idea that I'll show you later that should help keep the surface from getting beat up too bad. For this glue up, I was able to put my new domino jointer to good use, and give my wife a demonstration of this unreasonably expensive tool. I mean, it was totally reasonably priced, honey. The glue-up went especially well thanks to the extra pair of hands, and alignment on the boards was better than I was expecting, seeing as how they were too wide to run through my planer. With just a few minutes of belt sanding, the faces were ready for finish sanding, and then a quick truing up to final dimension and a few coats of water-based polyurethane. So the desk surface is done, 2 coats of polyurethane, sanding lightly in between so it's nice and smooth. Both sides, the upper shelf is also done. The legs are also painted and have had time to dry. So the next step is we're gonna be putting some threaded inserts to attach the legs and to attach the upper shelf. Then the fun really begins. To help make sure the hole for the threaded inserts is drilled perpendicular to the face, I used a drill press to make a guide block for drilling holes with a handheld drill, and used a piece of tape as a depth indicator. Things are starting to come together. Now that the base is done, it's time to start on the shelf. First step is locking these 2 pieces of aluminum together. This is gonna be the top shelf, but before we fasten it all to the desk surface, we're gonna first add a couple things. The first one being this aluminum extrusion. And the way I wanna do it is cut a groove in this top piece here, like that, so that it can actually go into this top slot and they can kind of seat together. Well, what do you know? Perfect fit first try. Using a dado stack and the table saw, 2 grooves are cut in the bottom side of the shelf to accept aluminum channels that will hold the LEDs and a light diffusing strip. Here I'm making some room for the LED wires to route. This will end up being covered by the shelf support. Now these LEDs are a bit special. They're super high CRI LEDs, meaning they'll provide almost ideal broad spectrum illumination, so the color of anything under these lights will be accurate and won't have the strange, not quite right coloring often caused by low quality white LEDs. The light is much more pleasant to work under and is a much better light to film videos with. To top it off, I'm adding a dimmer to control the LEDs. This dimmer doesn't quite fit as is, so the tabs need to be removed and new mounting holes added. Also, using tape like this to protect one edge while marking the other makes sneaking up on the perfect fit so much easier.
Houston, we have ignition.
To help keep the work surface clear, I'm also adding a magnetic toolbar to the right side support. Next, we need some mounting holes for the monitor arm. And if you're ever needing to get perfect alignment on some mounting screws, this trick with a piece of tape and the side of a pencil will help you get perfect spacing every time. I recently harvested these slim speakers from a broken flat screen TV. I also picked up this little amplifier board off Amazon to power the speakers. A quick 3D printed case will make these look a lot cleaner and make it easier to mount them to the underside of the top shelf where they'll be hardly noticeable. To fasten things together, I'm using these super slick brass heat set threaded inserts. You just melt them into the plastic with a soldering iron, and just like that, you've got some threaded holes in your 3D print. Not too shabby if I do say so myself. Now, I alluded to this piece earlier as a way to keep the desk surface from getting too beat up. I'm adding an inset strip of aluminum that will provide some protection to the front edge, but the main reason for it is as a sacrificial surface for cutting on and drilling into. And if it gets too chewed up over time, it'll be easy to replace. Now this piece by far is my favorite part of this whole project. It's a gantry kit that's made to interface with this type of aluminum extrusion. It provides a versatile mounting plate that rolls super smoothly along the length of the extrusion. More on this in just a minute. Everything's assembled and now it's time to get it in the office and set everything up. Since this desk is going to be partially used for electronics development, it's important to protect things from electrostatic discharge. This is an ESD mat that can be tied to earth ground using the single ground prong plug in the power strip. Connecting it in this way will allow the mat to dissipate any stored static charge of anything touching it. This computer will mostly be used for looking up datasheets and watching YouTube videos, and for that, a Linux-based Raspberry Pi will work just fine. It also has a small form factor, so it can easily fit out of the way on the back of the monitor. And now my favorite part of the build. This is a gantry system that's designed specifically for these V-channel aluminum extrusions. It gives a super versatile platform that you can then bolt anything to, and it glides like butter. For me, I'm most excited about the possibility on this desk, especially with really good lighting, to do this. Check it out. I quick 3D printed up a knob and washer, inserted a 1/4-20 nut, and just like that, I can mount a camera and get some epic top-down shots on a buttery smooth slide. I would say this has a ton of potential. And if you want a close-up, zoom it in right where you want it. I'm loving the possibilities that this thing adds. I'm thinking in the near future I'm going to add a microscope attachment option as well as a third hand option. Well, that about wraps things up. I'm super excited to run this desk through the paces, and I'm sure it's going to be a great tool on future projects and videos. I tried a bunch of new things on this build and learned a ton, and hope that this video also gave you some ideas of new things to try. Thanks for sticking around, thanks for watching. I appreciate each and every one of you. Take care.